this video, we will be talking about conic sections, specifically hyperbola and parabola. So in the last video, we talked about circles and ellipses. So to start with, this is a hyperbola as you can see in the illustration. A hyperbola is formed when a double cone and a plane surface connect. The intersection doesn't necessarily need to occur in the center. So as you can see, there are two lines that visible in the video in the illustration here and here. Okay, so there are two standard form of the equation of a hyperbola. So first we have x minus h squared over a squared minus y minus k quantity squared over b squared is equals to 1. As you have noticed, the equation of the hyperbola is similar to ellipsis. However, instead of plus, the operation we use is subtraction. And the other form of the standard form of the equation of a hyperbola is y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equals to 1. So these two standard equation form a two different graphs. So first one, let's solve this formula a equation A and equation B. For equation A, the form or the graph of the hyperbola faced to the left and to the right. So it will look like this. And for the second equation, for the B equation, it will face upward and downward. So it will look like this and it will look like this. Okay. And unlike the formula in or the equation in ellipsis wherein a squared is greater than b, in hyperbola it does not matter. We will be distinguishing with what is a and what is b depending on their appearance. First appearance, if for example, if the equation this certain number appear first, that is the a. Okay, so for example, we have the equation x squared over 9 minus y squared over 4 is equals to 1. So we need to find the vertices, which is the vertices. And then we need to find the center of the asymptote first, which is h and k. And then we need to also identify which is a squared and which is b squared. So for obviously we don't have the value of h and k, so the asymptotes intersect at the origin, and our a squared, which is 9, and b squared is 4. So a RA is 3 and B is 4. Now, to get the vertices of our hyperbola, we just use this formula or equation, since RA lies on the x-axis. Thus, the equation will be h plus minus a k. Thus, the vertices of the hyperbola is 3, 0, and negative 3, 0. Now, since we have those points, we will now plot those points on our Cartesian plane. Okay, here we go. So first, our as our vertices first. So 1, 2, 3 over here. 1, 2, 3. Then our asymptote, to plot our asymptote, we should look for the RA and B. So our asymptotes A plus minus B. Thus the points of our asymptotes are 3, 4, negative 3, 4, negative 3, negative 4, and positive 3, negative 4. Those are our points. 3, 1, 2, 3, 4. So here, 1, 2, 3, 4. Here and here. So it will look like this. Let's change the color of our pen to blue. So our asymptote will be looking like this one. Okay. Now let's draw our hyperbola. Here and here. Also we determine if the hyperbola faces on the left or right or up or down by simply looking RA, since RA has the variable x as its numerator. It is automatically that the form of the function is formula A, or the equation A. There we go. Next, we will be finding the foci of the graph. So to find the foci of the graph, we simply use the formula c squared equals to a squared plus b squared. Unlike the ellipse, the operation that is used in this formula or equation is addition rather than subtraction. So our A is 9 plus our B is 4, c squared, since c squared is 13, C is square root of 13. Now, just like how we use in or how we plot the foci of the ellipses last video, that is a process that will be used in plotting the foci of the hyperbola. So since our A lies on the x-axis, thus our to get the points of our foci or the coordinate of our foci, we will be using h plus minus c k. Thus, we will be having square root of 13, 0, and negative square root of 13, 0. Now, square root of 13 is approximately 3.61. So, it is somewhere around, wait, let me change our pen first. Somewhere around here. That's our foci. There we go. Okay. Now we already graph our hyperbola. Then last thing that we need to do is to find the equation for our asymptote. So the formula or the equation that we will be using is y minus k is equals to plus minus b over a times the quantity of x minus h. So this formula, please bear in mind that this formula is only applicable if a hyperbola opens to left and right. On the case that it opens up or down, the formula that we'll be using is y minus k is equals to plus minus a over b x minus h. Now, since our hyperbola opens to the left and right, so we'll be using the first formula instead. All we need to do is to substitute the variables. Thus, since there is no k and h, thus the formula will be y, the equation will be y plus minus our b is 4 and our a is 3 times x. That's our equation for our asymptote. Now, how about if we have an equation like this: x plus 1 squared over 25 minus 25 minus y minus 2 squared over 16 is equals to 1. First, we need to determine our a squared, our b squared, and of course, our h and k. So first, our a squared, which is 25 square root of 25, a is equals to 5. Our b squared is 16, square root of 16, our b is 4. Now, our h and k is the opposite sign of 1 here, which is negative 1 and positive 2. So now that we got our points, we can now graph our hyperbola. To graph our hyperbola and our Cartesian plane, first we need to plot the oops first we need to plot the center, or the intersection point of our asymptotes, which is 1, -1, and 2. So over here. Then, to find the vertices of our vertices, um, we need to use this formula, h plus h plus minus a over k. We will use this since our a lies on the x-axis. So -1 plus 5, 4, 2, and -1 minus 5 is -6, 2. So we need to plot those two. 4, 2, 1, 2, 3, 4 over here, and 6, 1, 2, 3, 4, 5, 6 over here. Now, next is we need to rise by 4 points and go downward by 4 points. This is to graph our asymptotes. So 1, 1, 2, 3, 4, 1, 2, 3, 4. Then here, 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 and here. Now let's first graph our asymptotes. Asymptotes will look like this, passing to our intersection point, and the other side. There. Then we can now graph our hyperbola. Since here's the vertex, so it will look like this. The other one will look like similar to that. Okay. Now we need to find our foci. So to find the foci, we use the formula c squared a squared plus b squared. So c squared is equals to 25 plus 16. C squared is equals to 41. Square root of 41 is 41. C is equals to square root of 41, or approximately this is around 6.4. So for plotting, our foci will be around 6.4. So 5.4, 5.4 around here, and of course around here. There we go. That's our foci. Lastly, we need to find the equation for our asymptote. So since our graph is facing the left and right, or opening to the left and to the right, we will be using the equation y minus k, not squared, y minus k is equals to plus minus b over a x minus h. y minus k. So y minus 2 is equals to plus minus 4 over 5 times x plus 1. So that's the equation of our asymptotes. So that's it for hyperbola. And moving on, last but not the least, is parabola. So parabola is formed when a circular cone is divided along a plane parallel to the cone slant or generator. So as you can see, the plane is slant, so there is a parabola created. So in parabola, there are possible four scenarios that you may encounter, or there are four um, what do you call this? There can be may, might be four appearance of parabola that you may face. Um, so let's draw it here first. Let's draw four partition planes. Oops. Okay. Let's use the easier method. Okay. Let's draw four Cartesian planes. One and two. Oops, that's not the Cartesian plane. Three. Less four. Okay. So there can be four possible scenarios for parabola. First is this one, wherein the parabola is facing upwards. Next is the parabola face downwards. Next is when a parabola faces or opens to the left, or when a parabola opens to the right. Okay. Now this is an example. This is where the equation for this one is y is equals to x squared. Here is y is equals to negative x squared. Here is y squared is equals to x. Then negative y squared is equals to x. So that's the scenario. Then the directrix here, which is x is equals to negative b. However, if your parabola faces or opens to the left or to the right, that will be y is equals to negative b in this case. And the distance between your directrix and your parabola is also the distance between the vertex of your parabola and your foci. So your foci for this scenario, your foci will be f is equals to 0p. On this one, the foci is located here, so foci a 0 negative p, so on and so forth. Now let's move on to the general equation of a parabola. So there are two general equation of the parabola. We have y minus k quantity squared is equals to 4p times the quantity of x minus h. This represents the y squared is equals to x. Thus, this one opens This one opens to either left or right. Next one, next formula is x minus h quantity squared is equals to 4p times y minus k. So this one, the equivalent is y is equals to x squared, which means opens to either up or down. Now, let's have an example. Number one, let's start first with a v6. Let's say y squared is equals to 8x. So immediately, it is the equation A. Okay, let's call this equation A and equation B. So immediately, it is recognizable that this is the equation A. Thus, we can expect that the parabola opens either to the left or to the right. Now, so since we have no hk, by the way, our h and k is our vertex. So there's no h and k, thus it is automatically that our h and k is the origin, 0, 0. Now, this is in the form of 4p times x minus h. So 8 is, can we can equate that to 4p. So 4p is equals to 8. Divide both sides by 4. Thus rp is 8. So graphing it, it can be look like this. First, oh no, sorry, rp is not 8, rp is 2. So from the origin, is the origin, our vertex, our foci is here, and our directrix is here. Thus, our directrix is x is equals to -2. Now, it is easier to say that the graph will be something look like this. However, we want somehow visually accurate or more accurate than a sketch. So what we can do here is we can assign a point and solve for a point. Since I think it is easier if we solve for x rather than we solve for y. So with that, y squared is equals to 8x. Divide both sides by 8. Y squared over 8 is equals to x. Now we need to think of a number that will give us a whole integer. Let's see. Let's try. Maybe we can try 2 as our y. So y squared 4 divided by 8.5. That also happens if we plug in -2. So -2 squared is 4. So thus it is the same. Next, how about 4? Positive -4. Right. Positive -4. 16 divided by 8 is 2. Same goes with -4. And lastly, let's try 8. 64, 8. Okay. Now we have our points. We can now graph for our parabola. Let's start with this 0.5 around here and positive and -2. So here and oops, my bad, here. Next, 2 and positive negative 4, so 2 4 over here, over here. Lastly, 8 1 1 2 3 4 5 6 7 8. Okay, it's also 8. 1 2 3 4 5 6 7 8 over here. Oh, wait, we're going to just move this one. Going to move this one for upwards. There we go. Okay, back to our solving. 8 8, so here 1 2 3 4 5 6 7 8, so around here. So we can now graph our parabola. It will look like this. Okay, there we go. So our parabola will somehow look like this. Next, how about we have another example. This time we will be having an equation, y minus 2 quantity squared is equals to 4 times x minus 3. So immediately this is equation A. Thus we will be expecting that our parabola will either open to the left or to the right. Now we have our HK, our H and K, or our vertex is 2, no, is 3 and 2. Then we can equate our 4 to 4p, so 4p is to 4 divided by both sides by 4 plus p is equals to 1. That means we will be shifting to the left by 1 to find our directrix, and we'll be shifting to the right to find our foci, or focus. Let's draw a Cartesian plane. On this time, let's try to make it somehow bigger, since we are extending on our first example. So first we need to plot this vertex. So 3 and 2, 1 2 3 1 2. So here, that's our vertex. Then our foci is just, let's change the color. Okay, so our foci is here, and our directrix will be found can be found here. So this is our directrix. Our directrix is y, no, not y, x. X is equals to 2. Okay. Now, just like what we did earlier, we will try to graph our parabola by creating a table of values and plugging in points for accuracy. So let's try solving for y. So let's try 4. So if we substitute 4 4 4 minus 3 is 1, so we will be left by 4. Square root both sides by 4, so y minus 2 is equals to positive negative. Wait, let's write it. Y minus 2 squared is equals to 4 times 4 minus 3. So y minus 2 squared is equals to 4 minus 3, 1 times 4, 4. So square root both sides by square root both sides. So we will be having y minus 2 is equals to plus or minus 2. So uh, y is equals to positive 2 minus 2. Y is 0. Another one, negative 2 minus, no, plus 2. This is 4. Plus 2, we'll be having y is equals to 0. So our y is 0 and 4. Next, let's try let's try 7 for x. So y minus 2 squared is equals to 4 times, no, not, yeah, 4, 7 minus 3. So y minus 2 squared equals to 7 minus 3, 4, 16. Another perfect square. So y minus 2 is equals to plus or minus 4. Y is equals to 4 plus 2. We will having y is equals to 6. The other one is y is equals to negative 4 plus 2. Y is equals to negative 2. So for 7, it's it's both 6 and negative 2. So let's now plot those points. First 4, 4, 0. So here, then 4 and 4, 4 here. Okay. Next is 7 and 6. 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6. Over here, and last one is negative 2, 1, 2, 7 over here. So we can now connect those dots to generate our parabola. So the parabola will be looking like this. That's it. And that's it for parabola. I hope there is something that you have learned in this lessons, and thank you for watching.